Okay, we're going to work through another example. This one doesn't have anything to do with the board or the width or the thickness or the distance. It's just P's and Q's in this example 1B. And in this case, they show P in that table. We'll call that X, and Q is our Y data. So step one, we need to write a general variation equation to see if these P values vary directly with Q for this data. So usually we would say Y equals K times X, but in this case we have P's and Q's, so we'd say Q, because that's like our Y, equals K times P, because P is like our X value. Now step two, we're going to solve for K. So we're going to use some points. If P is 1, Q is 4.5, so 4.5 equals K times 1. That means K equals 4.5. Step 3, write the equation, putting in K, our value for K. So we can say Q equals 4.5P. And in step 4, in this case, we're going to test it with all the other data. So we're going to use this next set of values. If P is 2, if we multiply 4.5 times 2, then our Q should equal 9. And that's what we get. When P is 2, Q is 9. Let's test it for the rest. When P is 3, we'll do the next set of data. Three times 4.5 is 13.5. That's really close to 13.6, which is good. If P is 4, 4.45 times 4, Q is 18. That's really close to 17.9. And the next one, if P is 5, 4.5 times 5 is 22.5. And that's what we get for the next one and the last one. If P is 6, Q should be 27.1. 4.5 times 6 is 27, which is really close to 27.1. So it looks definitely that P varies directly with Q for this data. Okay, now let's work on the next part of that board problem. The maximum weight is a function of thickness this time. So this time around, we're going to hold the width and the distance constant, and we're going to vary that thickness. So Perry then investigated the relationship between M, which is the max weight that board can hold, and the board thickness T. He held the distance D between the supports constant at 12 feet and the width W constant at 2 inches. He varied the thickness and measured the maximum weight that could be supported. So now example 2A. We're going to use the converse of that fundamental theorem of variation to determine how M varies with T and write a variation equation for this situation. Okay, so we need to use that converse of the fundamental theorem of variation. So we're going to select two data points. We're going to select T1 and M1 and T2 and M2 from the table, such that T2 is double the value of T1. So T2 should be double T1. Okay, we're going to pick T1, M1. We're going to pick 2 and 32. And then we're going to pick T2 and M2 such that T2 is going to be double T1. So if T1 is 2, T2 should be 4. So we're going to pick 4 and 128. So that set of points. So M2 over M1 equals 128. You see that? Divided by 32. And that equals 4. So as T doubles, M is multiplied by 2 squared, which equals 4. and that would be that fundamental theorem of variation. So let's test it again with two other data points, such that this time we're going to pick T4 triple of T3. So if T3 and M3, we're going to pick new points. We're going to say 1 and 8, and we want T4 tripled T3. So we're going to pick 3 and 72, because we want a number that's 3 times that thickness of that original one. So 1 times 3 is 3. So now M4 over M3 is 72 divided by 8, which equals 9, which is the same as 3 squared. So M does vary directly as the square of T. Okay, we're going to do another example, so hopefully you can get the hang of this converse of the fundamental theorem of variation. Okay, so we want to see how G varies with M. We don't have a variation equation, so we're testing them to see. And then what is the value of K? Okay, so we're going to pick some points. We're going to say G1 and M1, and we're going to pick 2 and 20. So these points right there. And we're going to do G2 and M2. And we want to pick G2 so it's double G1. So if G1 is 2, which we see, we want to pick double that. So we want G2 to be 4, and you can see that. So we're going to pick 4 and 80. Okay, so we know 2 times 2 is 4. That's how we got that G2. But now let's compare our M1s and our M2. So we can say M2 over M1 equals 80 divided by 20. That equals 4. So that is the same as 2 squared, which on our fundamental theorem of variation, that converse of it, we're talking about y equals, or the y values is they're multiplied by c to the nth when x is multiplied by c. So that's what we're working through. We're doing that converse of that. Okay, let's test it with some other points. So let's do G3 and M3 and G4 and M4. And this time we want to do, before we doubled it. Now this time we want to triple, just like the last problem. So if we pick 2 and 20 again, those same 2 points, we want our G4 to be triple that. So 3 times 2 is 6. So we're going to pick for G4 and M4 6 and 180. Because now we know that 2 times 3 is 6, but what is our relationship between M4 and M3? It's 180 over 20, those are my numbers, and that equals 9, which is the same as 3 squared. So M varies directly as the square of G. And we could test that with some points, and this might be an easier way to do it. We could say y equals kx squared, which with m and g's, we could say m equals k times g squared. Now let's plug in some values and see if it works. If m is 20, g is 2. If we solve for k, we get 5. I just picked the 2 and the 20 here. Now, if we know k is 5, we can say m equals 5g squared, and this should work with any other set of points on this table. So we could pick 5 and 125. So if m is, or if g is 5, 5 squared is 25 times 5, m equals 125. So it does work. We get those values.